Off, you're welcome to come in. We may want to do this a little bit in groups so people are able to take a turn. This is what we call a 3-wall cave. So 2 walls plus the floor. Everything is rendered in stereoscopic 3D. So what that means is when you're wearing these glasses, it's actually like you're in the room. It's got that full 3D experience. If we look on top of the room, you see these 4 red circles. These are motion capture cameras, and what they do is they detect the positioning of the glasses as well as the controller to determine how the user is positioned in the room, and the environment changes accordingly. So one thing I realize only one of you had the chance to try out that head-mounted display next door. One of the challenges with a head-mounted display is there could be temporary motion sickness, and the reason that is it's so immersive. Your mind's having one experience, but your body's having a very different experience, and that disconnect could create discomfort. It goes away. It doesn't take long for it to go away, but it's definitely there. When we're talking about a virtual reality cave, everything is customized according to what you're experiencing. So your body is actually part of the action. Your mind is part of the action, and if everything's set up properly, it should be a very comfortable experience. Now, why do we have a cave? What's a cave used for? Well, first and foremost, we could do a lot of human-machine interaction research here. So, when you have an environment like this, you can do all kinds of virtual reality environments and determine how people interact with that. We could also, there's also a lot of commercial applications. So, for example, let's say I'm going to put a building up. I could take the AutoCAD or I could take the digital source files and extrapolate them into something a cave like this would understand, and walk through the environment before it's actually been built. If I'm prototyping, if I'm creating a new car engine or a new car, I could take those assets, extrapolate what they would look like in a digital world, and walk around them, see them in a virtual environment, and I could probably save a lot of errors and aggravation by doing things before they're built in the real world, and save a lot of money that way. And then, there's another benefit too, which, one of our research expressed an interest in, is that look at the size of these walls. When we're talking about computer monitors, at most we're talking about 27, maybe 32 inches, which is very big on a desktop space. But if you need to make decisions, or you need to see how things interact, if we step away from the immersive benefits of a cave, we suddenly have all this visual space that we can use to get a bird's eye view of how everything's interacting. So it's very good when dealing with what we call big data and planning for big data. So these are just some of the uses for a cave like this. We're always, of course, discovering more, and it's a very new addition to the university. We're very excited about it because there's really only a handful of these in Ontario. Now comes the fun part where we actually get to try it. Would you like to give this a go?
How many scenarios do you have beyond this room?
Oh, we have we have several demos. Maybe 7, 8 demos.
I'm not just curious. What are they?
Well, we have, so the demonstrations aren't for necessarily practical purposes. They're there to exemplify what the technology can do.
I'm just curious.
So we have, we have a solar system where you can walk around the planets. It looks as though you're holding the planets. We have another one where it's kind of like a windmill, where you're walking through a windmill. It's like a similar environment to this, but it's just very, very different. We have another one where you're walking through a small town, and so you could go into the different buildings and kind of experience a little town. We have, those are just off the top of my head. We have about 10 of them. I can't remember everything. But
so is this a pre-rendered scene? Like how did you render this?
Sure. Okay. So this is all. Okay. So this is based on video game technology. Okay. So even though the medium is different, the core technology is very similar. We have what we call 3D assets, and it's what we do with those assets that determine how they're going to be projected. So what we could use with a cave like this, for example, is we could use a game engine like Unity. Unity is a huge independent game engine. It's actually free for if you're non-commercial, and we could take Unity assets and extrapolate them to something a cave like this would understand. For those unfamiliar, a game engine is like the building blocks of a video game. So you use a game engine to create your content.
So if you have 3D assets, can you actually place a 3D asset in the scene and allow someone to manipulate it?
Yes, but when we talk about manipulation, are we talking about changing it, or are we talking about...
Moving,
Navigation.
rotating it and...
Yes,
Yeah.
okay, so depending on the software that you're using, I mean, some of that would have to be coded, but there are demos that exist that let you manipulate things, like you can, pick up the chair and move it to another part of the room, or this is actually, you see, this is a simple interface. This is, the glasses, and of course you've got the controller, which is mainly used for moving around, but we have motion capture cameras here. So if we coded it accordingly, and let's say there's a couple things you could do. You could you could use a special wand, that you use to move objects around. If we were really advanced, we could have what we call, here, if you look carefully, notice how there's these little nodules on the controller, as well as the glasses. So it's these nodules that are being picked up by the cameras. So if we have, let's say, it's a similar technology to what they use in motion capture in movies, where they capture your movements and convert it into something digital. Well, we could do something similar here if we chose to be that advanced, where depending on how our body's positioned and our hands are positioned, we could have a gesture-based interface in here.
So Neil, on top of this, we also have the ability to interact between different modes. So for example, one of our students has created their own company with body armor, basically, that is touch effective. Like if you're in a car accident, you can feel the impact of the steering wheel in your face or whatever from the type of suit that you wear. You can put that person in the cave and have the software from the suit interacting with the software from, for example, a military procedure that they're undertaking.
And what about haptics? Have you done any research on integrating a haptic experience so that if you were to pick up the chair, you could actually feel the experience of picking up the chair?
Okay, so haptics is a kind of an interesting area. Actually, what Pamela was describing...
I don't know what haptics is.
Okay, so I'll explain, sure.
Touch.
So haptics
Yeah,
haptics is directly sense of touch. So when you have a phone and it rings and it vibrates, that's a form of haptics. If you have a joystick and it vibrates, that's a form of haptics. But there's even more advanced forms of haptics. There was a product, this is a couple years ago, I don't think they're on the market anymore, where it was a device you'd hold, and if, let's say, you were playing video games and let's say you were having a wand or a gun or something flying out of your hands, you'd feel the sensation in your hands. It could be very, very advanced. Now, as to a cave like this could be, somewhat a haptics device.